Alright everyone, so in this example, we have an officer tied to a set of cables. The cables are at different angles. We're going to set the X direction to be positive to the right, the Y direction to be positive upward. And so the setup for this problem is going to be very similar to the one we did in class. We want to find the tension in the two cables, which we call A and B. We can break these two cables, forces from these two cables into components using the angle given. We can do the same thing for B. And now we just want to set up our equations, the forces. So obviously the guy is going to pull down the force of gravity equal to m times g, which in this case is 73 times 9.8. And so the man has a force of 715.4 newtons. Now we're going to set up our two equations, starting with the x dimension. To the right is positive, then we have tbx minus tax, and that should be equal to 0. We can then use the angle to substitute for the component. And then we can use the decimal values for the angles, for the cosines of the angles, to find coefficients. For the y dimension, the two y components of the tension will add together. They'll be positive because they're pulling upward. And the force of the man, the weight of the man, is pulling downwards, so it's negative. And here again, we can replace the components with sine and cosines of the angles. So now we have two equations that we can use to solve for TA and TB. Now we can take those two equations, set up a system, solve for one, and then substitute to solve for the other. We can use elimination to eliminate TA, multiplying the top equation by 0.5736 and the bottom equation by 0.8192. Now using elimination, we can eliminate TA, solve for TB, and so you find that TB is equal to 590.49 newtons. And we can then use TB back in the original equation, the X equation, to solve for TA. By dividing, you find that TA is equal to 482.3 newtons.